Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to problems in the first paper of the 2014 JEE Advanced Physics question paper. I'll be following questions as they fall in code 1, but in any other code, the questions will just be shuffled up so you can match them for yourself. Let's move on to question 9. We are given a transparent thin film of uniform thickness on a convex spherical surface of radius r. So this is a surface of radius r, spherical surface at the end of a glass tube, and there is a thin film on it, and because it's a thin film we can basically assume that both sides have the same refractive index. And this has n2 is equal to 1.5, this has n1 is equal to 1.4, and this is air. And we are given that rays of light parallel to the axis going through the film from air to glass is focused at f1 from the film. So this is f1, somewhere where it's focused. And going from glass to air is fixed at f2. f2 is somewhere here. Actually, we can all tell that f2 will come out to be on the right side as well. It will be a negative focus from that point of view if rays are going in this side. But right now, just to try to tell you what's going on, we are taking rays going in this direction from infinity and going in this direction from infinity. Now, one thing I'll just immediately tell you is a lot of students would try to solve both these questions with this figure. And you can do that, but there's a very big chance, in fact, of making a mistake of a minus sign. So I would suggest that when you're doing it from air to glass, this is the figure you use, but you rotate the figure when you're doing it from glass to air to match with our convention that incident rays always go from left to right. Otherwise, incident rays go from right to left, so you have to take right to left to be the positive direction. Right? And you can do that in your head, but there's a chance of making a mistake. Right? So in the second case, we'll assume that the rays are going like this, which is the same as if rays are going like this. The answer will be the same. Right? So in both cases, we'll have two reflections on a spherical surface. What is the formula for reflection on a spherical surface? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. And both sides have the same radius of curvature r, both towards the right. So both positive. Right. So the first equation for air to glass will be 1.4 by V minus 1 by U, which is infinity, is equal to 1.4 minus 1, that is 0.4 by R. And R is not given, we'll just have to find the answer in terms of R. So which gives me 0.4 V is equal to 1.4 R, or V is equal to, this is 4 by 10, this is 14 by 10, so 14 by 4, 7 by 2, 7 R by 2. So V for the first one is 7 R by 2, and this is a thin film, so that will be U for the second one. We don't need to change anything because this is not a thick lens or two lenses separated by a distance. Right? So just like we do for a lens, we do two planar surfaces. Right? And we could actually, if you wanted to, try to use the lens formula, but in the lens formula you have the same medium on both the sides. Right? So you have a medium of lens which is a mu1 and medium on both sides same which has mu2. So we can't use the lens formula in this particular case. But you could try to do this as air to film to air and then going to glass immediately afterwards. Right? It does give the right result. So this equation gives us V is equal to 7R by 2. So for the second one, that will be U. So for the second one, 1.5 by V minus 1.4 by U, which is 7R by 2, is equal to mu2 minus mu1, 0.1 by R. Again, R is still positive. Right. So this gives me 1.5 by V is equal to 1.4 by 7, this 2 by 5, 2 by 5 R plus 1 by 10 R, which is, this is 4 by 5 R plus 1 by 5 R is 5 by 10 R, so 1 by 2 R, which means final V, or rather mod F1, which is the final place where they'll come, is equal to 3R. So we can say that option A is true and option B is false. Now to find F2, from which we'll tell option C and D. So I'll just rub all this. It's just, this question is quite easy, just straightforward application of two reflections at the spherical surface. The only big confusion is, and I'm sure a lot of students would probably make a mistake in that point, is they'll try to do the second case from here, taking this to be the positive direction. Then this R and this R both have to be negative and everything has to be taken accordingly. And if you do that, you will get the right answer. But there's a chance of you making a mistake. Right. So if we do it in this fashion, then initially this is 1, this is 2 and this is 3 now. Right. So mu2 by V, that is 1.4 by V, minus mu1 by U, that is 1.5 by infinity, is equal to mu2 minus mu1, that is minus 0.1, that is minus 0.1 divided by R, but R is also minus R in this case. You see why it might make a problem? I'll repeat the signs. We are going in this direction, so U is infinity, is actually minus infinity, but it doesn't matter. This is the second medium, this is the first medium from our perspective of refraction. So mu2 by V minus mu1 by U is equal to mu2 minus mu1, that is minus 0.1, divided by R, the radius of this surface, which is in the negative direction because this is the direction of incident light. So which gives me 1.4 by V is equal to 1 by 10R, or V is equal to 14R. For the second one, 1 by V minus 1.4 by U, U is now 14R, is equal to minus 0.4 by minus R again. So which tells us 1 by V minus 1 by 10R is equal to 4 by 10R. Right, 0.4 is 4 by 10, this is 1 by 10. So which means 1 by V is equal to 5 by 10R, which means V or mod F2 is 2R. So along with option A, option C is correct and option D is wrong. Right? Straightforward application of the formula. Thank you.